Okay, hello everyone. Today we will continue to talk about network layer. Last time we have learned the format of IPv4 protocol. The header format is shown in figure 46. Now we know the header format of IPv4 includes these fields, including version, header length, DS field, total length, identification, the flags DF, MF, and fragment offset, time to leave, protocol, header checksum, and source address, destination address, then followed with options, 0 or more words. We should understand the meaning of each field, including versions, header length, IHL, header length, and version, DS, total length, etc. And we will have exercises about the protocol analysis. Then we will, these questions will emerge in the homework or the final examinations, final assignments. Today, we will continue to talk IP address. We know the main points about network layer includes IP protocol, routing, addressing. So then the IP address, every host and router on the internet has an IP address that can be used in the source address and destination address fields of IP packets. It is important to note that an IP address does not actually refer to a host. It really refers to a network interface. So if a host is on two networks, it must have at least two IP addresses. Last week, we have conducted experiment 2, and probably we can understand we configured an IP address for a certain network interface, right? So, however, in practice, most hosts, most end systems are on one network and thus have one IP address. In contrast, routers have multiple interfaces. Routers are some special hosts. So routers can be looked as special hosts, which connected to multiple networks with multiple interfaces. So routers should have multiple IP address, at least one IP address for one interface. IP addresses are hierarchical, unlike Ethernet addresses. Hierarchical means the IP address format. The IP addresses format includes network portion and a host portion. Each 32-bit address is comprised of a variable length network portion in the top bits. This is a network portion in the top bits and a host portion in the bottom bits. So IP addresses are hierarchical. The network portion has the same value for all hosts on the single network, such as an Ethernet LAN. This means that a network corresponds to a contiguous block of IP address space. This block is called a prefix. So, what is the meaning of prefix? It is a concept in the network, in the internet. It means a contiguous block of IP addresses usually belong to a single network, such as an Ethernet LAN or a physical network. IP addresses are written in dotted decimal notation. In this format, each of the 4 bytes is written in decimal from 0 to 255. For example, the 32-bit hexadecimal address 80D00297. It is with 4 bytes. It's written as 128.208.2.151 in dotted decimal notation. This is 128 is a decimal notation, and each byte described as a dotted notation, a decimal notation, and it includes 4 bytes, right? 4 bytes. So 80 in hexadecimal, that is 128, right? Hexadecimal 80, hexadecimal 80, hexadecimal equals what? 8 times 16 plus 0, right? 80 hexadecimal equals 8 times 16 plus 0. It is 128, right? So the highest, the topmost bit, the byte is 128. It is the same for the other bytes. So prefixes are written by giving the list the IP addresses in the block and the size of the block. The size is determined by the number of bits in the network portion. The remaining The remaining bits in the host portion can vary. This means that the size must be a power of 2. The power of 2. If the length of the host portion is x, then the size of the network block, is the x's power of 2, right? X squared of 2. By convention, it is written after the prefix IP address as a slash, followed by the length in bits of the network portion. In our example, if the prefix contains the eth power of 2 addresses, and so leaves 24 bits for the network portion, it is written as /24. Why? Because the prefix, the network address block, contains the eth power of 2. That means the length of the host portion is 8 bits. So the length of the network portion must be 24, because 24 plus 8 equals 32. 4 bytes. That is the length of the IPv4. Sometimes prefixes are simply described by their length, as in this form, /16. The length of the prefix corresponds to a binary mask of ones in the network portion. When written out this way, it is called a subnet mask or net mask. It can be ended, and it is a mathematical calculation with IP address to extract only the network portion, and drop the host portion. That is the function of the mask. For our example, the subset mask is 255.255.255.255.0. Then this is a typical subnet mask of Class C network. The figure 48 shows a prefix and a subnet mask, and is the total length of IPv4 address is 32 bits. Then this is prefix length, capital L. The remaining length 32 minus L. So the network portion has L bits. The host portion has 32 minus L bits. The network mask means with all bits has the 1 bit in the network portion, but all 0 for host portion. So the mask and the mask end with any network, then drop the host portion, then extract the network portion, because this bits all 0. So and the host portion then means dropping the host portion, extract the network portion. It's usually used for routing, because routing refers to find a path for a packet, find a destination network for a packet. So that is what the routing want to do, find a destination network. So they can use subnet mask to get the network portion. Hierarchical addresses have significant advantages and disadvantages. The key advantage of prefixes is that routers can forward packets based on only the network portion of the address, as long as each of the networks has a unique address block. The host portion does not matter to the routers because all hosts on the same network will be sent in the same direction. So the network portion is more important than the host portion. It is only when the packets reach the network for which they are destined that they are forwarded to the correct host. This makes the routing tables much smaller than they would otherwise be. Consider that the number of hosts on the internet, the number of the hosts on the internet is approaching 1 billion. That would be a very large table for every router to keep. However, by using a hierarchy, routers need to keep routes for only around 300,000 prefixes. So this hierarchical addressing makes routing table much smaller than they would be. This is the advantage of the hierarchy addressing. While using a hierarchy, this internet routing scale, it has two disadvantages. First, the IP address of a host depends on where it is located in the internet. An internet address can be used anywhere. An Ethernet address can be used anywhere in the world because the Ethernet address is flat, not hierarchy. But every IP address belongs to a specific network because the IP address has network portion and host portion, and routers will only be able to deliver packets destined to that address to the network. Designs such as mobile address IP are needed to support hosts that move between networks but want to keep the same IP addresses. So the hierarchy IP address make the mobility more difficult. The second disadvantage is that the hierarchy is wasteful of addresses unless it is carefully managed. If addresses are assigned to networks in large blocks, there will be many addresses that are allocated but not in use. So the hierarchical addressing will be wasteful for some addresses. Some addresses probably are not used. They are wasted. That are allocated but not in use. This allocation would not matter much if there were plenty of addresses to go around. So if the total number of addresses is very, very large, then it doesn't matter. However, it was realized more than 2 decades ago that the tremendous growth of the internet was rapidly depleting the free address space. IPv6 is a solution to this shortage, but it is not widely deployed yet. Actually, IPv6 is being widely deployed nowadays. Now we will talk about subnet. Subnet means if the network portion is too large for a certain physical network, we can part the whole block into some subnets and then make the IP address used fully. Network numbers are managed by a non-profit corporation called ICANN to avoid conflicts. In turn, ICANN has delegated parts of the address space to various regional authorities, while route out IP address to ISP and other companies. This is the process by which a company is allocated a block of IP address. Routing by prefix. Now, what's the meaning of prefix? What's the meaning of prefix? Prefix means a network address block, a network with block. So by prefix, we requires all the hosts in the network to have the same network number. This is a address prefix with same prefix. Then this is host portion. So this is a prefix. This is a prefix. This is a prefix. It requires all hosts in the network to have the same network number. This property can cause problems as network grows. As network grows, it can cause problems. For example, consider a university that starts out with our example /16/16 prefix for use for the computer science department for the computers on its Ethernet. A year later, the electrical engineering department wants to get on the internet. The art department soon follows suit. what IP addresses would these departments use? Getting further blocks requires going outside the university and may be expensive or inconvenient. Moreover, the /16 already allocated has enough addresses for over 60,000 hosts. Why? Here is over 60,000 because /16, then the length of the host portion is 16. So this prefix has 60,000 hosts. This is 64,000. It may be intended to allow for significant growth, but until that happens, it is wasteful to allocate further blocks of IP addresses to the same university. So a different organization is required. The solution is to allow the block of addresses to be split into several parts, split into separate parts for internal use. For internal use as multiple networks, while still acting like a single network to the outside network, outside world, outside network. So this is called subnetting, and the networks that result from dividing up a larger network are called subnets. The scheme named subnetting. So this, for example, this is a computer science department with this subnet. WE department have this. The art department have this. The three subnet all belongs to the original network block with prefix of /16. So this figure shows the splitting an IP prefix into separate networks with subnetting. The single /16 now has been split into three pieces, right? 3 pieces. This split does not need to be even. Some pieces may be large, some pieces may be smaller. So, but each pieces must be aligned and so that any bits can be used in the null host portion. In this case, half of the block is allocated to the computer science department. A quarter is allocated to electrical engineering department. /18. The eighth, the /19. So the size are different to each other. Why the original size is 216, the original size. Then y /19 is the eighth of the original size. Why? Because the /19 the size is 232 minus 19. This is the size of the host portion, right? It is 13. So it is the eighth of the original size, right? A different way to say how the block was divided is to look at the resulting prefixes when written in binary notation. Binary notation. The original prefix is this. And they are split up into 3 pieces. Here set 0 for CS department. Set 00 for EE department. Here Y is 00 because this bit is 1. This bit is 1. So this bit must be 0. Must be different to the 1. So here is 0. Then the second bit set the smallest one, 0. Then since this is 00, so this 2 bit can be set with 0, 1, 0, 1. So this is 0, 0, 1. Then the third bit can be set 1 or 0. 1 or 0. So we will have exercises the next class. So probably you cannot understand these subnetting scams very well. It doesn't matter. We will have some exercises the next time. When a packet comes into the main router, how does the router know which subnet to give it to? The routers simply need to know the subset masks for the network on campus. The router looks at the destination address of the packet and checks which subnet it belongs to. The router can do this by ending the destination address with the mask for each subnet and checking to see if the result is the corresponding prefix. So the router can find the destination network and forward the packets to that one. For example, consider a packet with destined for IP address, this one. To see if it is for the computer science department, we end with the subnet mask, this one, to take the first 17 bits, which is this one, and see if they match the prefix address, which is this one. They do not match. 255 means all 0. All 0 for this byte. All 1 for this byte. 255 means all 1 for this byte. 1 128 means 1 zeros for this byte. This 0 means all 0 for this byte. Checking the first 18 bits for the electrical engineering department, we get this one when ending with the subnet mask. This does match. This does match that prefix address. So the packet is forwarded onto the interface, which leads to the EE network. That is why network subnet is used for routing. Even if blocks of IP addresses are located so that the addresses are used efficiently, there is still a problem that remains. Routing table explosion. Routing table explosion means the number of entries of routing table becomes very large with the increasement of the number of networks. That will make the network runs with very low efficiency. So routing table explosion should be avoided. Routers in organizations at the edge of network, such as a university, needs to have an entry for each of their subnets, turning the router which line, which interface to use to get to the network. For routes to net destinations outside of the organization, they can use the simple default rule of finding the packets on the line toward the ISP that connects the organization to the rest of the internet. The other destination addresses must all be out there somewhere. Routers in ISPs and backbones in the middle of the internet must know which way to go to get to every network. No simple default will work. These core routers are said to be in the default-free zone of the internet. No one really knows how many networks are connected to the network anymore, but it is a large number, probably at least 1 million. This can make for a very large table. That is a routing table explosion, very large table. It may not sound large by computer standards, but realize that routers must perform a lookup in this table to forward every packet. And routers at large ISPs may forward up to millions of packets per second. So routers should forward the packets arrived rapidly. But if the routing table is very, very large, that the looking up efficient is very low. So routers cannot forward the packets rapidly. That degrade the performance of the whole network. So specialized hardware and fast memory are needed to process packets at these rates, not a general purpose computer. In addition, routing algorithms require each router to exchange information about the addresses it can reach with other routers. The larger the tables, the more information need to be communicated and processed. Right. So to reduce routing table size, to reduce the routing table size is important. We can apply the same insight as subletting. Routers at different locations can know about a given IP addresses as belonging to prefixes of different sizes. However, instead of splitting an address block into subnets, here we combine multiple small prefixes into a single larger prefix. This process is routing aggregation. Routing aggregation. Combined multiple small prefixes into a single larger prefix. So the routing table contains a single larger prefix for multiple small prefix. So the routing table size can be reduced. This process is called routing algorithm. The number of table size, the number of routing table entry, the size can decrease. So the resulting larger prefix is sometimes called supernet to contrast with subnets as division of blocks of addresses. That is, know the basic IP address schemes. 1. The basic IP address schemes. 2. The subnetting. 3. CIDR, classless interdomain routing. 4. IPv6. So this is the development of IP management. Basic IPv4 scheme, subnetting scheme, CIDR schemes, IPv6 or 5 net with private network. So here we talk about CIDR after subnetting. Now, let's have a rest for 10 minutes. Let's have a rest for 10 minutes. Keep connection. Keep connection to network.
哦，完了完了，阿九。